Morning, everyone. Let us start this session. So, in the previous session, we started with the module number 3, which is a friction. So, we discussed the basic concept of the friction, the difference between static friction and the kinetic friction. And after that, we were discussing about the definitions. So, first is the coefficient of friction. So, coefficient of friction is the ratio of limiting frictional force to the normal reaction. Okay. So, when we say the ratio of limiting frictional force, that means it is the max value. Okay. So this definition, it is for static friction. So when we mention the limiting frictional force, it is only the static condition. Okay. So from this, you can write the equation for the static friction or coefficient of static friction, which is a mu s. This is equal to F max upon normal reaction. The next is the kinetic friction. When the object is in motion and the frictional force act on the object, that frictional force, this is called as a kinetic frictional force. Okay. So the coefficient for kinetic friction is mu k. This is equal to Fk upon normal reaction. Okay. So where Fk is the kinetic force of friction and Fk is always less than F max, and therefore the coefficient of static friction, which is a mu s, is always greater than mu k value. Okay. Okay, then we have seen the angle of friction. So angle of friction means the angle made by resultant of the limiting frictional force. So this is the limiting frictional force, which is called as a F max, and the normal reaction. So resultant means we have to find out the resultant of F max and n. So this is the resultant. So angle made by this resultant with the normal reaction, this is called as an angle of friction, and it is represented as a phi. Okay, so from the angle of friction, you can find out directly the coefficient of static friction. So we know F max is equal to mu s into normal reaction. Okay, or coefficient of static friction from the definition, this is equal to limiting frictional force, which is a F max upon normal reaction. Okay, so from this we can write F max is equal to mu s into normal reaction. Okay, and then you can write the equation for resultant as R is equal to, so basically this is the x component of resultant and this is the y component of resultant. Okay, so we know the formula for resultant, it becomes a concurrent force system at this point. So we can write F max square plus normal reaction square. Okay, so if you put the value of F max, which is a mu s into n, then you will get one equation for resultant. Okay, and then if you use the formula for tan phi, which is equal to the F max upon the normal reaction. So F max is equal to mu s into n upon normal reaction. Okay. So from this you will get one equation for tan phi, and that equation is mu s. So if in the problem, instead of coefficient of static friction, the phi value is given, then you can find out the coefficient of friction by using this formula. Okay. The coefficient of static friction is equal to tan phi. Okay, so this is the angle of friction. Then the next definition, it is the angle of repose. So what is angle of repose? Just imagine there is one object with mass m and it is kept on one horizontal plane. Okay. So initially the angle is 0. Okay, because plane is exactly horizontal. Okay, and there is some friction between this object and this plane. So let us assume this friction to be mu s, which is a coefficient of static friction. So what is angle of repose? Just imagine we start increasing the angle of this plane. Okay, and there will be one condition: when this block kept on this plane, it will start sliding down. Okay, so that angle of the plane, this is called as the angle of repose. So here you can see in the animation what is meaning of angle of repose. So just I am increasing the angle of that plane with respect to horizontal, like this. At certain condition, object will start sliding down. Okay, so this angle of that plane with respect to horizontal or with respect to x-axis, this is called as the angle of repose. So it is given as a theta. Okay, so I hope we have understood what is meaning of angle of repose. So again, observe the animation. Initially, angle of this plane is 0. Okay, we start to increase the angle. At a particular angle, object starts sliding down. Okay, so this angle is nothing but the angle of repose. Now, from the angle of repose, you can find out directly the value of coefficient of static friction. Okay, so all these are experimental procedures to find out the angle of friction. Sorry, to find out the coefficient of friction. Okay, so one is to find out the angle of repose. Okay, so let us see how to find out the coefficient of static friction from the angle of repose. Okay, so just imagine initially we have one plane which is exactly horizontal and we kept one object on that plane. Okay, now we start increasing the angle. Like this. Okay, at a particular angle theta, the object is on the verge of motion. Okay, so meaning of verge of motion is the object has a tendency to slide down the plane. Okay, and verge of motion is such a condition that at this point the frictional force developed, it will be the maximum friction, that is called as a limiting frictional force. So this force will be F max. Okay, and this is equal to mu s into normal reaction. Okay, so suppose just imagine this theta angle, let us take this 30 degree. Okay, at theta 30 degree we get the maximum frictional force, so it becomes the limiting condition and object is on the verge of motion. Verge of motion means still the object is in static condition. So beyond this value 30 degree, even if I increase the angle by 0.1 degree, so if I make the angle 30.1 degree, so at this condition immediately object will start its motion in the downward direction, and that condition will be the dynamic condition or the kinetic condition. Okay, so we have to find out the limiting condition. So 30 degree, it will be the limiting condition. Okay, so here just I have taken 30 degree as an example. So let us take theta is the limiting condition, and at this condition we have the maximum frictional force and object is on the verge of motion. So this is the verge of motion condition. Okay, so at this condition we will try to draw the free body diagram. Okay, so here I will draw the free body diagram. So this dotted line, it represents the plane. This angle is theta. So the first force on this object, it will be the weight force. Okay, so this weight force, it will act exactly downward direction. So right now this is the W, which is equal to mg. Okay. So whenever we deal with the inclined planes or we analyze the system for the inclined plane, assume this direction as a x direction along the plane and the direction which is perpendicular to that plane as a y direction. Okay. And then resolve the forces along x direction and along the y direction. Okay. So one force W, it is exactly in the downward direction. Second force will be the normal reaction, which is offered by this plane on this object. Okay. So that normal reaction will be exactly perpendicular like this. And this perpendicular to the inclined plane. So this is your normal reaction. So here you can show the normal reaction like this. And this is perpendicular. Okay. Next force is the frictional force. So frictional force will be always tangential to the contact surface. So this is the frictional force like this. So here you can observe this frictional force, which is a F max. It is exactly along the x direction. Okay, so right now it is on the negative x direction, but it is parallel to x direction. But this W, it is inclined with this y axis and the x axis. Okay, normal reaction is exactly parallel to y axis. So just we have to resolve the force W. Okay, so just I will draw here the line of action. Okay, so here you can see this angle is 90°. This is theta. Okay, so if you want to resolve this force, you can resolve the force at this point. So I will draw the component. So this component, it is parallel to y axis, and this component, this is parallel to x axis. Okay, so just extend the line of action for the y component of W. Because we don't know the angle of this y component or this x component, so we have to find out that angle. So this is theta. Here we have the 90°. Okay, so this angle, this is equal to 90 minus theta. And again observe this triangle from this point. So in this triangle, this is 90 minus theta. This is 90. So remaining angle will be theta. Okay, that means angle of W with respect to y axis, this is theta. Now you can resolve the W along y axis. So this is the y component and it is an adjacent component. So this is equal to W cos theta. This is x component and it is the opposite component to angle theta. So this is W sin theta. Okay, so you can resolve this diagram like this. So here I have shown the force at this point. So you can show the force like this. This is the W. Okay. Then here we have the normal reaction. And at this point, we have the frictional force. So right now you can show the component. One along x direction or along the plane, and second along the y direction or perpendicular to the plane. So this angle, if I extend this line, so this is theta. Okay, if this is theta, then this y component, it will have the same angle theta. Okay, so now you can resolve. This is the adjacent component, so it is a cos component, and this is the sine component. So similarly, I have shown here W sine theta, and this is W cos theta. Now here, when we consider the limiting condition, that means F max force, it means that object is in static equilibrium. Okay, so here we can use the condition of the static equilibrium. So what are the conditions? Summation fx0 and summation fy0. Okay, so just use summation fx0. So just consider all x component. So here w sine theta acting in the positive x direction. So we have to consider this reference axis. So I will write here w sine theta. This is a positive. This f max, this is a negative. So minus f max, this is equal to 0. Only two forces in the x direction. Now consider summation fy. So summation fy, this is equal to 0. So for summation fy, we have w cos theta. But if you observe this reference axis, then it is acting in the negative y direction. So it is a minus w cos theta. Then this normal reaction towards positive y direction. So plus n, and this is equal to 0. Okay. So from this, you will get the equation for normal reaction, which is equal to w cos theta. Okay. Now here we have the f max. So you can put the value of f max, which is equal to mu s into normal reaction. So w sine theta minus mu s into normal reaction. This is equal to 0. Okay. So from this equation, you will get w sine theta. This is equal to mu s into n. Okay. So here we have got w cos theta is equal to n and w sine theta is equal to mu s into n. So just I will write this equation. W cos theta, this is equal to n. Okay. So take the ratio. So 1 divided by 2. So you will get w sine theta upon w cos theta. This is equal to mu s into n upon n. Okay. So w we can cancel this. So remaining is sine theta upon cos theta. So it becomes a tan theta. So tan theta, this is equal to mu s. Okay. So if you know the angle of repose, that means the angle of plane for which objects will start sliding down, then you can directly find out the coefficient of static friction by using this equation. Okay. Tan theta, this is equal to mu s. Now refer the previous definition, which is the angle of friction. So for the angle of friction, we got the similar relation. So from the angle of friction, which is the phi, we got the equation mu s, this is equal to tan phi. And from the angle of repose, which is the theta, we get the equation mu s is equal to tan theta. Okay. And therefore we can write tan phi, this is equal to tan theta. Okay, because for the same plane, coefficient of static friction will be same, and therefore the phi is equal to theta. Okay, so it means that the angle of friction, this is equal to the angle of repose for this same plane and same object. If you change the object, you will have the different value of coefficient of static friction, because the coefficient of friction, it depends on the two contact surfaces. Okay, so if you take this block, which is made up of some wooden material, okay, and if this plane is the glass, then these two surfaces, that is contact surfaces, will have some constant value of coefficient of static friction. So it may be 0.3, 0.4, it depends on the surface roughness. Okay, but if you change the object or the material of the object, instead of wood, if you take this metal, okay, aluminum, steel, okay, or any other metal, then you will have the different value of coefficient of static friction. Okay, But for this same contact surface, the angle of friction and the angle of repulse will have the same value. Okay. So for your exam, there can be question to prove this whether phi is equal to theta. Okay, or show that the mu s is equal to tan phi. So this is the derivation. So you can expect one theory question on this friction. Okay, so I hope this is clear. What is the angle of friction? What is the angle of repulse? And what is the relation between angle of friction and angle of repulse? Both are having the same value. The next we have the definition of cone friction. So what is a cone friction? So if you apply a force P on an object which is kept on one surface, and if you change the direction of that force, direction of the force P through 360-degree, then the resultant R generates a right circular cone the resultant R generates the right circular cone with the semi-vertex angle equal to phi, with semi-vertex angle which is equal to phi. Okay, so this cone, this is called as a cone friction. So I will draw the diagram, then you will understand what is the meaning of cone friction. So we have one object having the mass m, and it is kept on one surface like this. Okay, and we apply the force P on this object. So right now this diagram is drawn on the two-dimensional plane. Okay, so just we are observing the front view of that object or complete system. Now just imagine, so at this condition, I will draw the forces on this object. So this is the frictional force, and for the static condition, this is the F max. We have the normal reaction, which is the N. So there will be resultant of these two forces, F max and N, and this is the resultant R. Okay, so the angle made by this resultant with the normal reaction, this is nothing but the phi value. Just we have seen that, which is called as the angle of friction. Okay, so this diagram, as we are observing in the front view, so just consider this is one plane. Okay, so you will observe this just like an triangle. Okay, now just imagine, we will draw in 3 dimensions. Okay, so it is the same object which is having the mass m, and just observe, you are looking from this side. Okay, so this is the observer from this side. So if you observe from this side, basically we are applying the force P on the object, and here we have the frictional force like this at this contact surface, and this frictional force is F max. Okay, just I will extend this up to the center, and at this point we have the normal reaction like this. Okay, so if you observe from this direction, observer, then you will observe this front view. So you will just observe the triangle, which is a right angle triangle. This is normal reaction, this is the resultant, so I have not shown the resultant. Okay, so this is the result. Okay, and this angle, this is the phi angle. Now just imagine you change the direction of this force P in 360 degree. Okay, so you are not changing this angle, you are changing angle in this plane, horizontal plane. So consider this is one vertical axis, and about this axis you are just rotating the force P in this direction. Okay, so what will happen every time you change the direction, this resultant will also rotate in the same plane. Okay, so here we will get one cone with this semi-vertex angle like this. So as you change the direction of force P, this resultant will also change its direction, and it will try to remain in the same vertical plane like this. Okay, and therefore you will get this complete cone with this semi-vertex angle phi, and this is called as a cone friction. Okay, so here again you can read the definition. If you apply the force P on an object which is kept on the surface, and if you change the direction of the force P through 360 degree, then the resultant R generates a right circular cone with the semi-vertex angle phi. Okay, so this is called as a cone of friction. So actually this is cone of the friction. Okay, so now we will solve some problems on the friction, that is a static friction, and we'll try to find out the value of frictional force and value of the unknown force P required to cause the motion.